Hello and welcome to the practice problems video for double angle identities. Alright, here's number 1. We're given if sine x is equal to 1 over 8 and x is in quadrant 1, then find the exact values, without solving for x, our angle, for these three things. Okay, so first of all, sine x is equal to 1 over 8 and x is in quadrant 1. So we have some kind of thing going on here where we have sine, so here's like our angle x, and it's in quadrant 1. Right? So we can draw a triangle. Let's say it looks like this or something like that. Here's theta, okay? And, sorry, not theta. Usually we use theta. But let's say this is our angle x, right? And that's 1 over 8, so that would be opposite over hypotenuse. So we could figure out this other length down here, let's call it a, by using the Pythagorean theorem. So 8 squared is equal to 1 squared plus 8a squared. Okay, so a squared is equal to 64 minus 1. So a is just going to be equal to the square root of 63. This is equal to the square root of 63. So that means we could solve for cosine of x using the sides that we do know now. So that would be adjacent, radical 63, over hypotenuse, which is an 8. Okay? And this is going to be positive since we're in the first quadrant. And we can also just simplify this into saying, well, this is like the square root of 9 times 7, so that's 3 times radical 7 over 8. Okay, so now we know what cosine x is, so we can go ahead and tackle these problems. So a is sine of 2x. So according to our double angle identity, this is equal to 2 times sine x times cosine x. We were given the sine x, so that's 1 over 8. And we found out our cosine x, so that would be 3 times radical 7 divided by 8. Okay, so this is actually something like 1, and then we can cancel that out with a 4 on the bottom. So this will be a 3 times radical 7 over a 32. Okay, so that's part A. Now let's work with part B here. B is equal to, we're going to solve for cosine of 2x. Okay, and now let's say we just want to use the 1 minus 2 times sine squared x. So when we use that, we get 1 minus 2 times 1 over 8 and squared. Okay, so this is like 1 minus 2 over 64, which is the same thing as saying 1 over 32. So 1 minus 1 over 32 is like a 32 over 32. Sorry, I'm squishing it in down here. Minus 1 over 32. So that's just going to be equal to a 31 over 32. Okay, so that's our cosine of 2x, and on the next slide we'll solve for tangent of 2x. Alright, so now let's say we have tangent of 2x, and it's like, wait, we don't have a double angle identity for that, do we? No, but we do know that tangent is just equal to sine over cosine, right? So, and we figured out both of these, this one from part A and this one from part B. So sine of 2x was equal to 3 radical 7 over 32, and cosine of 2x we solved to be 31 over 32. So when we divide those, we get 3 times radical 7 over 32 times 32 over 31. The 32's cancel out, and we simply get that tangent of 2x is equal to 3 radical 7 over 31.